Welcome everybody to this lunch lecture done by Van Rossum. I would like to introduce you to Floor Vermu, who will give the lunch lecture. So please take it away.
Well, hello, my name is Floor Vermu. I'm with Van Rossum Raadgevend Ingenieurs, and I will tell you something about the project The Puls in Amsterdam. I will first tell you something about myself and then introduction about the company. And then I will go into the main load-bearing structure of the Puls and some unique aspects of the engineering. And I will end with a Q&A. So I studied at the Technical University of Eindhoven and I did a Master of Structural Design. And when I finished, I started at Van Rossum Raadgevend Ingenieurs in Rotterdam as a structural engineer. Van Rossum has 4 offices, one in Amsterdam, that's the headquarters, one in Rotterdam, that's where I am at, and one in Almere and one in Utrecht. We also have the possibility for an internship or graduation at Van Rossum. It's about 10 interns or graduates that work here. At Van Rossum, we work with a lot of the same clients. That's how we build trust, and they know our worth. We are an involved partner with an eye for detail. So when they work with us, they know they get a good end product. And communication is key in the cooperation with these clients. Okay. We stand for Integral Design Team. So we communicate with the architect and the contractor and the clients all to get a good end result. And the end result should be a building that's easy to construct, not expensive, and also good on the eyes for the architect. Projects that we work on, these are all in Rotterdam. We have the top left, the Coal Tower, which is 150 meters high. It's being built right now, and we can see it when we look outside our window from the office, because the office is a little bit on the right on the picture. I don't know if you can see my arrow, but it's over here, our office. And next to the Coal Tower, you can see the Baan Tower. It will be built after the Coal Tower, also a project of us. It's 158 meters high, and both towers are residence towers, built on a small plot in the middle of the city center with existing piles beneath. So it's a complicated project. And then the bottom right is Boompjes, we call it, but it's called Clubhouse officially. It's next to the Maas, and it will be a little bit with overhang over the road. This one is especially complicated because it's in between 2 water lines. So for the foundation, this brings a lot of difficulties. Okay. My personal experience, I think Van Rossum is really young. Well, not really. It's we have a young team. It's most people are around 30 years old, and one thing is also very important at Van Rossum is that you learn through experience, and especially by asking a lot of questions to your colleagues. That's how I learned in 3 years how to build these kind of projects. I started with the project to see below. It's the Mall of the Netherlands. That's the largest mall in the Netherlands right now. It's just opened last month. I started first with calculating a few steel beams for escalators and elevators. And then in the end, I was the project leader of this project for all the attendance changes. So there are 300 to 400 shops inside the mall, and every shop wants elevator, escalator, and lift. And these all need to be constructed, the holes in the floors and the structure to opvangen van of the escalators. These are heavy structures. Okay, and the Puls, the project I'm going to tell you about, you can see over here. It's located next to the train, the railway on the Zuidas. And you can see over here all the projects we do at Rossum at the Zuidas, or we worked at. And at the dot, you see the location of the Puls. Over here, there's the station of Amsterdam Zuid and Amsterdam Rai station. So, the buildings built here. The Puls is a building designed by two architects, MVSA and VMix, and also a landscape architect helped on the design for the forest on top and designed into the building. It's Delva. Our client is Forum and the contractor is Forum Bouw. These are different parties, but it's the name. And we work in the design phase with one project leader, one structural engineer, and one draftsman. And I am the structural engineer of this project. And in the end phase, more structural engineers and more draftsmen will help. As you can see over here in the section of the building, there's a lot of different functions. There's an office tower. That one is designed by MVSA. There's apartment tower that's designed by VMix. And then the midsection is offices, a cinema, also residences, apartments on the other side, and commercial facilities like restaurants and cafes. And beneath the whole plot is a parking garage. The difficulty in this project lies also in the demarcations, so the section between the two architects, because it goes crisscross through the building. So sometimes it's VMix, and then the other time it's MVSA, and we need to be the overlap between these different designs. Here you can see the total structure of the Puls. The midsection has on the top part, it starts with a thick concrete slab for the forest on top, and then it will go into over in columns with hollow core slab floors for the offices, and beneath that there's on this side of the building residences with walls and floors, and on the other side you can see over here the cinemas with also walls and then hollow core slab floors, and it all is resting on top of a basement of 2 layers. And then there's the office tower. It's completely built with concrete columns and a thick concrete floor slab. Stability is gained by the concrete core. And then the residence tower is built on the top levels with steel to make the different facade of the building. Because of the different facade of the building on the top, we made it in steel. And then towards the 8th level, it's all designed with walls and concrete floors. And then below, it will go over into offices also. So there, the structure will have columns and beams again towards the bottom. I will start with the midsection of the building. Here you can see the residence side of the midsection, and then on top you can see over here the offices. In the facade, it's really visible what the demarcations are. So VMX does all the red brick part, and MVSA does the white facade part. Another difficulty about this project is the many different functions in the building. for a good structural design, you need to have vertical lines. So the load can go from bottom to the top part to your foundation. And if you have a lot of different functions, they all have different placements of their structure. So cinema is very open, apartments are really closed, offices also need to be open, and parking is specified by the cars and the parking way. So in the design phase, we try to connect all these functions so that to the foundation it has straight lines. And over here you can see these columns go straight down towards the walls of the apartments, and then in the end on the walls of the parking, and then to the foundation. And in the cinema you have a transition structure to get the large open rooms. So you get large beams beneath your columns. The forest on top of the building weighs around 20 kilonewtons per square meter. So that one is, it's really heavy. That's why you get these thick beams. And over here you can see the straight lines going up. Okay. Another difficulty about the midsection is the many dilatations we have. The cinema needs to be acoustical dilated, so no vibrations can go into the residents that are next to it and the offices. And also because the building is quite large in length, we need to have 2 dilatations horizontally. These dilatations give problems, not really problems, but we need to design the stability of the structure differently because of the dilatations. So you can see here in a section, the top part, the wind goes to the core of the midsection. You can see over here the core, and the sides also have kretteuvels, so know the English word for it, to get some part of the wind load to the 2 towers. The bottom part of the building is stabilized also by the core for the cinema part, but the other side where the residents are, the apartments, all the walls work for stability. Over here it's completely dilated from the next door buildings, only for the vertical loads. It's not dilated. In the midsection, it's the only structure that has beams and columns structure with floors on top of it, as you can see over here, and that gives problems for your installations. Offices have need to have a minimum height of 3.6 meters, I think, and these are the floors are exactly 3.6 meters high. And to get these installation pathways, we put some integrated steel beams into the structure so that the installations can go from one side to another. As you can see over here, it's a lower structure than the normal prefabricated concrete beams that the hollow core slab is placed on top of. And the residence tower, you can see over here that it has a lot of different shapes in the facade, and our task is to make a simple structure that can make all these different shapes possible. The way to do that is still with walls, because residence towers are usually made with a lot of walls and floors. And to make all these different facades possible, we just retracted some of the walls into the building. As you see over here, some of the walls are inside, and some of the walls in the bottom level will then be to the outside. And the upper part is the open steel structure for the penthouses. The residence tower will go onto the office part, and from residence to offices will be walls to columns structure, and to get the overlay or to get the loads of the walls into the columns, you need a large surface for the krachtinleiding. So over here you can see a lot of beams beneath the walls to get the loads into these columns beneath. And the office tower. This tower has a lot of repetition compared to the residence tower. It's the same from almost the same from top level till the 10th floor. Then it has a different core. The core will be larger from the 10th floor till the bottom. But for the rest, it's a column structure with a concrete floor slab. In the design phase of the building, we discussed a lot of different structure methods. So we looked at steel beams with hollow core slab floors and prefab beams with hollow core slab floors, or concrete beams with concrete floor slabs. In this phase, we looked at the doorbuiging. I don't know the English word at this moment, but how much the floor will hang, and we looked at the strength of the floor, and then we communicate this with our clients and also with the architect, and then in the end we choose together with them which option is the most is buildable and inexpensive. They chose in the end for a complete flat floor, hollow core, not hollow core, concrete slab of 450 millimeters thick. And to make it lighter, they put Kobiaks elements into the floor. The difference with bolleplaatvloeren is that it's all one concrete layer. It's not that there's first a slab of concrete prefabricated and then this is put on top. It's all one part of the same concrete, so you don't get the shear forces on the two different layers. Then we used a SIA model to see the stability of the structure, especially the office tower has a difficult shape for the wind forces, for the stability, because it will want to rotate. The core is positioned not symmetrically in the building. This part of the building will want to rotate one or the other way. And you can see over here, we look at the vorvorming of the tower. And this way we designed the core thickness. So in the end we had to have walls of 500 millimeters thick, and the walls, the holes in the walls, so for the doors, they also have set measurements, because if they become larger, the they will become larger. Another thing that we as engineers have to work with is design questions of or design options of the architects. This is the entrance of the office building. They wanted no columns here in the office, in the entrance, and right above this part, in the point of the building, there's a line of columns till the top of the building. So we need to make a transition structure over here to make sure there's no column on the bottom. And you can see it over here. There's these 3 columns that will, this column will get, will pull these floors up and will bring a tensile force into the floor to the core of the building. And these slanted columns will bring the pressure forces towards the structure, which will also go into the floor of the building, but then the lower part. These kind of structures will bring difficult details because you have concrete and steel together and all these forces need to go into your building. It's designed with a steel beam for the tensile forces with a lot of rebar welded to this steel beam so that the tensile forces can go into the floor. This part of the building can only be built with a temporary column beneath, and then when this floor is completely hardened, then the rest of the building can be built and this column can be removed. Because if this floor is still wet, the tensile forces cannot go to your core and then the structure will not work the way it's supposed to. The foundation of the building is 2 meters thick concrete foundation blocks. Because of the loads, the heavy floors and the high loads of the office building, this one has 1 large foundation block, and the office the resident tower is has lower loads, so it's possible to have a foundation of a few smaller foundation blocks over here. And in the middle section we have the parking garage. This one is made with parking lifts with 3-story cars. And there's no space to go, well, it's not possible to go lower in the ground without a lot of bemaling. So the walls of the parking are also your foundation over here. In these kind of projects, the ground of the Zuidas is very good to make these kind of projects, but you cannot go really deep because of the water pressure over here. So two-story parkings is about the maximum that's built in the Zuidas. Are there any questions?
I have a question.
Yeah.
Okay. About the foundation. So it seems like there are a lot of different functions in the building causing different loads, and it's quite wide. Doesn't it create different settlements in the foundation?
Yeah, good question. It does. So the top part of the building is dilated, and the bottom part, as you can see over here, is not dilated.
Okay.
We will resolve this by putting a lot of rebar into our structure, so that it can take the forces of your shrinkage and settlements.
Okay, thank you.
Concrete was used as the main structural material for large parts of the building. Were any other materials considered, and what are the main advantages that you used concrete in such a large part of the structure?
The main reason is that the client has a partner they work with called Red Beton, and they told the client that they can build with concrete really fast, and well, fast means cheap. So in the end, that's why we chose concrete for a lot of parts of the building. That answer clear?
Yes, thank you.
Yep.
I have a question. You repeatedly mentioned the low cost of the structure. Also, just at the last question, do you feel that there were some compromises or concessions made when discussing the budget of the project and the design thereof?
One is the flexibility of these floors of the office tower. Is that they are not flexible because of these Copiax elements. So if you want to make a hole for stairs later, it's not really possible because these elements cannot really handle shear forces. But I think in the end, concrete is really flexible in the way you design the building. So the cost did not influence the design. Is that a clear answer?
Yes, thank you.
You told that you have 2 different architects that you work with.
Yeah.
And they're even on top of each other's project. Didn't that cause any problems?
Yes, it did a lot. Here, this wall you can see, it's the north facade of the building. The architects of the top part of the building, VMX, wanted it placed as far as they could to the outside, and the columns beneath are of MVSA, and they wanted to place it inside because the facade needs to go around the columns. But these are, I think, about 10 stories or 12 stories above that the wall carries the floors above. So it's a large load that goes in this wall. If the wall is placed far from the columns, then you get a moment in your floor, in your beams, that you need to bring the moment to the columns and the floors.
You just did that with more rebar, or do you have another solution?
Well, in the end, we made these beams higher, and we made 2 rectangular columns over here, so that they can get the moment capacity of your columns is higher if the dimensions are bigger. And the wall was firstly placed a lot further from the columns, and in the end, in the design phase, they decided that it could be more on top of the columns. So now it's not that big of a problem anymore. The rebar can go straight from the wall to the column. It's good for your moment capacity.
Right, thank you.
I also had a question. First of all, thank you, Floor, for your presentation. I was wondering in how specific are the 2 towers designed in terms of function? You said 41 tower is for residential and the other is for office. Could it be shifted in the future? How are they flexible in that sense?
They are flexible in the sense that the floor height is the same. Mm-hmm. Normally for residential buildings, you have max floor height, I think, of 3.3 meters. And here they are all 3.6 meters. But the residential building has a lot of walls, and these walls are needed for your stability of the building. So to get an open structure, as they mostly want for office buildings, is then difficult. So in that case, it's less flexible to make the residential building an office building. The other way around is possible, I think, because columns are never a problem, almost never. So you can make walls on top of your floor for the offices. Also, the loads of offices are over here at 4 kilonewtons per square meter, and for the residential building we put 2.5 kilonewtons per square meter. So I think the other way around is possible, but offices on the residential building will be difficult.
All right, very clear. Then another question also about flexibility. Are the ducts or the lighting work, is it all also cast in situ, or are those ducts also flexible?
The ducts are mostly in beneath your floor.
All right.
And in a residential building, it is possible because of these high floor levels. But the difference in these ducts is that for offices you need a lot more ventilation, so larger shafts than in the residential part. So I think if you make an office in the residential part, then it will not fit anymore to get these ducts through.
All right. Thanks.
If there are no more questions, then I think I would like to thank Floor for this very interesting lunch lecture, and thanks for everyone for attending. Very nice, such a big group from Rossum was also attending. It's very fun to see. Thanks again, Floor, and thanks everyone for attending, and I hope to see you all at the next activity.
Okay, bye. Good afternoon, everybody.